My name is Bob Morrison. In this video I will be providing a comprehensive introduction to the OptoLyzer Studio version 1.4.2. The K2L product portfolio consists of an entire family of OptoLyzer Mocha devices, starting at the Mocha CL, which supports CAN and LIN. The Mocha CLF has CAN, LIN, FlexRay. The Mocha FD has CAN, LIN, FlexRay, and CAN FD. The Mocha Compact, CAN, LIN, FlexRay, and most. And our OptoLyzer Mocha LAN has CAN and Ethernet messages. The OptoLyzer Studio features a state-of-the-art GUI with ribbon bars, dockable and floating windows, numerous views, workspace, trace, graph, disassembly, filters, activities, tiles, device manager, data views, and replay functionality. In addition, we provide catalog support for each of our supported networks: CAN, CAN-FD, LIN, FlexRay, MOST, and Ethernet. Our hardware setup for this demonstration consists of a laptop that is running OptoLyzer Studio version 1.4.2. It is connected via RS-232 interface to our CAN-FD evaluation board, which has firmware on it which is generating a stream of CAN-FD messages, and using control commands over the RS-232 we can tell it to change the bit rate that it's using or the data length of the messages that it's sending. In addition, we have a dial head unit with a wheel and numerous buttons that is connected via normal CAN interface to our OptoLyzer FD. And this is connected via USB interface to our laptop. So when messages are generated by our head unit, sent via CAN to the OptoLyzer Mocha FD, that goes via USB to the laptop. And then there's a small program that is checking these CAN messages, and it generates the appropriate commands for our evaluation board, so he will then change the bit rate or the data length. The OptoLyzer Studio has been freshly installed on this laptop and started for the first time. And we see it comes up with only one pane, the Workspace pane, and we see that there is a new Workspace. And the first thing we want to do is save the Workspace. And we want to go to my demo directory. And we'll put them in here, call it CAN FD demo. We'll save this guy. Now, the first thing we need to do once we've saved our workspace is we want to configure any devices we have. We only have one device. That's our OptoLyzer Mocha CAN-FD device. We see it's called device 2 at the moment. We can change it to anything we want. Let's call it OptoLyzer Mocha FD. Now I need to make the window wider. And if we open up the box, we see the three networks that are supported: FlexRay, LIN, CAN. We're interested in CAN. We see there's 6 CAN interfaces, 2 of which are CAN-FD interfaces. And we can set the bit rate that we want to use directly from a drop-down combo box. For FD, there's 2 bit rates that need to be set. In our demo, we're going to go between 1 megabit and 8 megabit. That can be controlled by the wheel. And basically, that's all we need to say about this. We've configured it. The bit rate I'm going to do with my special control wheel with our program. So we can now get rid of him. Let's open the system info. Let's bring him there. Let's look at the interfaces he has. In addition to the CAN, LIN, FlexRay, he also has a trigger ECL. It's an electric control line. And if I open the CAN, we see we have the same 6 CAN interfaces. We see the mode that it's set up in and the bit rate. In addition, if I look below the items, we see statistics, sent, received, errors, and last error. So now I want to start my demo. And if it works right, if I press the wheel and rotate it, I see that I can change the bit rate of the CAN-FD interface. So we'll just leave that at 8 megabit. Now if we look at the received, we see that there are CAN-FD messages coming in. So we would like to view those messages. So there's two locations where we can start an online view. First of all, we could press the hotkey, which is F5. We'll open a new trace view. There may only be one running trace view at a time. You can have many ones stopped and create a new one if you want, or you can reuse the old one. So let's use the big button here. Doesn't matter. Takes a few seconds, and then we'll start see the CAN-FD messages coming in. Let's make a little space. We can do best fit all columns. Let me increase the data length a little bit because I can modify the data length using my drive wheel here. And now let's take a look at a secondary window. There's trace and graph. We want to demonstrate the trace secondary window first. It has an interesting fixed position trace mode. And now we see only one line. And this is the CAN-FD messages coming over CAN2 with an ID of 16 or 10 hexadecimal. So, and the nice thing about this is you see the different types of messages. When I activate my control wheel, there's 3 different types of IDs that will go over the CAN1, and then we will see one line for each of the different IDs. So let me do that now. I'm just going to push the wheel, and we see there's 3 different new messages that have appeared. And now we'd like to take a look at the data associated with these messages. So let me go to the disassembly window first. Plug them in here. Now here we have for the data frame some basic information, and then the specific is in the payload here. We don't see too much. Let's open up some other data windows, the bit dump and the hex dump. The bit dump is going to be used mostly for CAN-FD and LIN messages, and most messages would normally use the hex dump. And it looks pretty boring. There's the data in there, but we don't have much of a help. Well, we need to add a catalog, and I have one prepared. So I'll add a CAN DBC catalog for my demo head unit. And now we see that in the payload, instead of an array of bytes, we see nice signals defined, and they have colors associated with them. And we see those same colors in the bit dump and in the hex dump window. And if I select a particular item in the disassembly, they are marked in the bit and hex dump. I can also select bits or bytes individually in the bit and hex dump, perform certain operations on them, copying in different formats. And if I double click on an entry, then it automatically selects it in both windows, and that goes for anyone. Now we don't have to use the disassembly window. We also have a detail view in our trace window, which is very helpful. Let me add a filter because the CAN-FD messages aren't too interesting at the moment, so let's get rid of those and just look at our CAN1 messages. And then if I select one of my dial status messages, then I can use this expander and I get the same information as in the disassembly, separated in tabs, and the signals are exactly as we saw in the disassembly. And then I can open another one. Here's the next message, dial status, and I can pick the signals there. And we see we could compare them. Now a very nice feature of the trace view is we can create our own columns extremely easily. I can do that directly from the custom columnizer here, where all of our columns are defined. For example, I also have the catalog in here. I can open that up, and then I can drag a particular item here and drop it onto the columns, and then it creates a new column. I can do the same thing from one of the detail views, creates a new column, and I can do it also from the disassembly view. Take the rotation value. And now we see that only the dial status messages from which these signals are defined have values associated with them in the column, and the all other messages, those columns are empty. And to remove columns, we can simply drag it down onto the trace view, or we can right click and click hide column. Either method works fine. Now I would like to demonstrate the other secondary window, the graph. Let's make it a little bigger. And since I can influence my data length, I would like to change this filter again so that I'm seeing the CanFD messages. I select a CanFD message. I want to get to the data length. And then I can drop the data length onto the graph. And we see then the data length is 20 bytes, which is where I started it at. And if I change it, I can see it in the graph. And in the graph, I can also select. I can zoom around, do whatever I want here. It's all very nice. Now let me turn that filter back on again, get rid of the CanFD messages, because I want to select one of my dial status messages again, and I want to drop some properties here. Let me first drop this counter. So, and then let me drop this rotation value. And now we see that we don't see our other two signals very well because the rotation value is such a high value. It's over 32,000. So what we can do to correct that is use a different y-axis, and now he's properly scaled on his own axis, and now I can see my 0 to 20 without any problem. So that's much nicer. In addition, we can look here, and we have a marker capability. And what this is every message that has generated a data point for our particular signal is either a rectangle that is not filled or filled. If it's not filled, the value has not been changed. And if it's filled, the value has been changed. So here we can see that my counter, the value was changed each time. There were only 8 messages that were received for the counter. And for the rotation value, we see that it hasn't changed. And even though that we've got a range of like, what do we have, 12,000 range vertically, we know that it's not changed because the rectangles are not filled. And if we look at the CanFD messages, it's tough to see anything because there's so many points there. So if I zoom in a little bit further, then we can see it better. Then we see all the points where a CanFD message came, and then the one where the data length was changed for that particular CanFD message. Now the graph is the proper way to view a signal over time. We want to see the changes in the value, but what if we just want to see the current value for certain signals? So for that, we can use the quick tiles or a tile file, either one. And let's adjust this so we can see the graph and the tiles at the same time. So now we've got them over there. And now I'm going to drop the data length. So let me enable the Can2 messages again, pick any one of them. And now I can grab this data length and I can drop it on here. And now I see there are 4 different types of tiles that I could use for this data length. I'm going to pick the gauge tile first. It's one of the prettiest. And we see we have a nice gauge, as you might see in your auto. And it shows the current value of the data length, which is 20 bytes. Now I'm going to drop it again, and I'm going to use an image tile. And we don't see him because he's flowing around, so let me make flow break so we can get him at the same time. And now what's important is we need to, for the image tile, define certain conditions. We can either define conditions however many we want with different values in it, and then we have to associate an image with it, which we either have to have gotten from somewhere or have created ourselves. That can take quite a bit of effort, so the quick method is to use our red, yellow, and green LEDs. So let me do that. Define these LEDs, and let me specify what color I want for what range. So if he's greater than or equal to 0, I want him to be green. If he's greater than 20, I want him to be yellow. And if he's greater than or equal to 50, I want him to be red. And now if I change my rate, I see green, but I don't see any other colors. Well, I've got the order wrong. The conditions are executed from top to bottom, and the first one will always be true, therefore it will always be green. So what I need to do is move the green down to the bottom and the red up to the top. And then if I go through, then I see my yellow, and then I go up here, but I don't see my red. The ranges are wrong. Well, what did I do wrong now? Well, I changed back to hexadecimal mode up here, and if you notice there's a little blue box and it has a 16 in it. That's telling me that it's interpreting these numbers as hexadecimal. So even though I entered it in decimal, he took it as hexadecimal. So let me turn that off so that I'm in decimal, and then if I re-enter my 20 and my 50, and then step through, then I see that the colors are now the way I want them. I can also make the colors match. You see, notice there's a color bar here in the gauge. I can turn it off, and I can change it so that the values are exactly the same. So I can make that 20, 21, 49, and 50. And now we can see by just looking at the gauge that the values are properly interpreted, and that means that when I change the value, that it's going to be properly coordinated between the two. And let's quickly define the other two types. There's a text, and with the text, it simply shows the value. There are, of course, options that could be used on that as well. And if I change to hexadecimal mode, then I see it in hex. And we also have a nice progress bar. Pick the progress bar. Let's change its size, make him large. And he is also by default at 100. So we go up here and let's make him 64. I can also add conditions and make the colors the same colors, or we can just leave it here. And let me also change it to use the value instead of showing the percentage, because the percentage we see automatically. So, and now, let me adjust this a little bit smaller. So, get it in here, and now when I change it, we see that 64 is 100%, and we see the value, and it's in hex at the moment, and if I click this, then it's in decimal, and so they're all coordinated now. Go back down to 20. Now I'm going to demonstrate a very useful function, or replay function. So let me start by clearing, I could use the quick toolbar here, clearing all our messages. So we have our data length is currently 20, and we have our CAN-FD messages coming in, and now I'm going to send a series of CAN messages so that my little program on the laptop sends the command so that it changes the data length the message is being sent. And this is all being recorded in our trace window. So let me go down to 8, go back up, go back down. So that's all we need. So now we can stop the trace, because what I want to do is set a filter for these messages, these status messages. So in order to do that easily, I'm going to get rid of the can2 messages again. I can select my dial status, and then what I want to do is define a quick filter and go here and take the can ID and drop it in here, and we see it's defined a dial status. So now I'm going to activate that filter. I can turn off the can2, I don't need that anymore because now I have a user defined filter. Do that. So now we only see these dial status messages, and now what we want to do is export them filtered. In other words, only what I'm seeing here with my filters activated, and I want to create a new folder, call it replay, and go into that folder and then name this change can FD data length. So save. Then we can add this replay file. Now it's in the workspace. Well, I don't have a nice folder for that, so let me make a folder here as well. New folder, replay. Let me plop him in here. So now he's in the replay folder. Let me open him. And now the most important thing to think when you're working with a replay file is someone else may have recorded this as well and sent it to you, and he may have different devices and different channels, and I want to play it on my device on my CAN1 channel, but it may have come from somewhere else. So what I have to do is go to replay mappings, and first of all I have to pick the source, and that was in my case my FD CAN1, and then where I want to send it to, and in this case I want to send it to my Mocha FD CAN1 channel. Without this, the replay will not work, and then I can save it because this was a change to the file. And now I can move this over here because I want to see the graph at the same time when I do this replay. So let's restart. And let me clean off the filters so I can see the messages coming in. So I have my nice graph. And let me get rid of these unneeded series. So let me do auto scroll. And let's make it a little bit bigger. It's a little bit too big. Get it down here, so something like this. So now we're ready. We can see with the graph and with our tiles what the value for the data length is. We have our messages where we've done our replay mapping to the proper channel. So we can select our replay file and then we can say replay all. And now we see that the data length is being changed. Matter of fact, let me go here and turn off these markers because they're too thick. So go down there, and now he's done. So we could stop again. We can go here, take a look at this. So we can see that exactly the same sequence of messages were sent with the same delay that I used originally. And this is great for stimulating your system. Now, another way you can stimulate your system is to use activities. So I can open a quick activity and I can send a cyclic tan data frame. I'm going to make it repeat 3 times, and I'm going to use a message of 123 hex and some appropriate data, and change the data length to 3. So, and now let me also make a filter for the same thing. I'm going to use a general filter to be sure to get out everything other than what I want. And I'm going to pick a can ID, and again we see the 16 here because I changed it to 16. So 1, 2, 3. So that's hexadecimal. So now I've defined a general filter that will only display my messages. So now I can go here, and in the trace it is stopped at the moment. And let's activate my general filter. I should not have any of these messages, and I don't. So now let me restart. Clears everything off. And now I can go to my quick activity, and then I can press it. And now if I look here, I see the 3 messages that I sent with ID 123 hex. Now another feature of our log files and our replay files is we can add bookmarks. So let me click on the replay file, and let me click up here in the navigation and add a new bookmark. And we see there's a blue rectangle, but I don't really see anything else. So what we want to do is view our bookmarks. Let me put him over here, and let me do a best fit all columns. Let me get rid of this creation date. Let me hide the group panel. So now it's kind of the way I like it. So, and we have 3 different types or categories: error, warning, comment. They each have a different color. And make this first message. I can add a note, start of the sequence, and then I can go somewhere else in the file, and I can also use Control-B hotkey to define it. Now we see another comment. I'll make it a warning, turns the rectangle yellow. I'll say lucky number 13 and somewhere over the rainbow. And I'll go to the end here and pick one more, hit Control-B, and I'll turn this into an error. It becomes red, and I'll say last message and end of the sequence. So now, first of all, we can see that there is a tooltip that shows the title and the notes. And if I click on one of the bookmarks, it jumps to that location. So, and we also see that the replay file has now been modified. So if I close him, he's going to ask to save it. I say yes. And now we notice that there's an icon of a lock to the left of our bookmarks here. And if I look at the tooltip, it's telling me that I need to open the file by double-clicking. So if I double-click, he opens it in the document area. We see our tooltips, and we can jump to them. Now there is one more window that we should definitely look at, and that is the recorder. Now the recorder is pretty simple. It has a rather extensive context menu. It also has the ability to filter, but not with user-defined filters, only with devices and protocols and channels. and it records directly to a file. And you can define a split size by going to the options, at which he will stop recording in one file and start in another file without losing any messages. And there's a few other options you can set. I like to create new subfolder. We'll see that yet now. If I start recording, we see messages are coming in and it's going into this file. And the file is gray because normally I can click on it and view it as a trace view, but I can't do that when it's recording. But when it fills up this file and goes on to the next file, then all the other files that were already completed could be viewed. So in order to speed this up, we'll just do a stop. I can click on this hyperlink. It opens up the view. So I can do whatever I want, filtering, graphing, analyzing. And now we have a nice rename function for all the session files. We can pick some new name for the base. Say can fd demo run 1. And now it changes the base name for all of our sequence of files to that name. You see it also changed it up here in the one we were viewing. And then we have two other nice functions. We can pack them. This will bring up a dialog where I specify a zip file, and then all of these log files will be packed into the zip file. And once I've done that, then I could delete all session files if I want to save space. And then, for example, I could send that zip file to a colleague because he wants to do some analysis on it. Now, up to now, I've only talked about the quick filters, quick activities, and quick tiles, but you can also have filter files, activity files, and tile files, and any number of them. For example, for tiles, you may have certain properties or signals that you want to watch at different times. So it might make sense to create different tile files, and then you can open one tile file at one point, and then you can close it and open another tile file to see the different signals that you want to look at. The same goes for activities and for filters. So what happens when you've been using this quicker capability, you don't have to define a file, you can just double click and you can work with it. And we can export this. So for example, my quick filters, I can export it. I can go here, I can create a new folder called filters. And then I can go into that folder and I can say my filters. And now I have created a new file that has exactly the same info in it as the quick filters, these two filters. So let's do it here. Let's add a filter file. And there he is, my filters. And if I double click, he'll open them. And there, if I expand them, I see I have the same two filters in there. So now I can go and delete my quick filters. I wanted to delete the quick filters and deleted my filters, no problem. All our documents have undo, redo. So I click undo, undo. Now I've got it back. So now I can go to my quick filters and I can delete those quick filters. And then if I close this file and say save, now the quick filters is empty, but I didn't lose my filters because I now have a file, my filters, defined. If we take a look at the file menu, the first thing we see is new workspace. As I mentioned, that's how you want to start a new project. Create a new workspace and just put in it what you need. As a developer, I do it for different bugs. I'll create a new workspace. Open allows you to open any of the files that you have done recently. If a file has been deleted, then it will show as gray, and then you can remove the obsolete, or you can clear the list. And save, you see everything that is currently unsaved, and you can check them individually or all. The pack is a very nice function. That is for the workspace. You can also access it from here, pack workspace. These files could be anywhere. They can be on my network, on a USB drive, on my hard disk somewhere. and I want to send a colleague exactly what I'm working on for whatever reason. And it would be a pain if I had to go to each one of these locations and collect the particular files together and send it to them and everything. So we have this pack function, and when you execute it, it uses the references, it finds the file, it copies the file to a local directory, and then it modifies the workspace to use that relative reference and puts that all in a zip file without, of course, changing your setting. And then you could change that, send that zip file to a colleague. He can unpack it in some directory, and if he opens the workspace, he'll have his links in there, and if he double clicks on them, they'll be able to open it because he properly delivered the files with the references to it. Your situation will be unchanged. Your files will still be where you put them. But it's a very powerful feature when you're working with someone else on something. So the options dialog I already mentioned shortly. There are also general options, directory for payload highlighting, FlexRay, there's a couple. You can see the license, you could open up your license control, and you can also see what plugins are being used for the system here. So, and the last thing left is to exit the program, and he knows which files have been changed, and he asks if you would like to save them. If I cancel, I'm still here. If I say no, it won't save anything, and if I say yes, he will try to save everything, except for something that's never been saved. Then he asks me for a file name or to verify the file name, and in this case I could say cancel, and he will still close, and then we're done with that. Now the OptoLyzer Studio is sold in different software editions. We have the Entry Edition, which supports the microchip CAN bus analyzer or the LIN serial analyzer. We have the Foundation Edition, which supports all of our Mocha family of devices, compact LAN, CLF, CL, CAN-FD. And the Professional Edition supports all that, plus there's a code generator and the ability to combine your own test code with the OptoLyzer Studio test framework. This ends my presentation. I hope it was helpful for you. For further information, you can go to our OptoLyzer Studio product page on the K2L website. If putting that link in is too tough, you can go to the k2l.de and pick product, software, CAN-FD, and then OptoLyzer Studio. Likewise, we have a K2L channel with a number of videos and tutorials on YouTube. The link there is also a little bit difficult to enter, so if you go to the YouTube main page and enter K2L GmbH and search, then our channel will be right on top. Thank you for your time.